So we'll begin with our very brief look at the calendar. We just finished our 4 classes on voting. So we're done with all the voting stuff. Maybe that's good news, maybe that's bad news, I don't know. Now the next 2 classes is another topic called weighted voting, and you might say, well, wait a minute, the word voting is still there, but rest assured this is a very different kind of topic than the one that we had before. Everything that we've done in the first 4 classes has been relying on the idea that one person gets 1 vote and we're all equal in terms of how much power we have when we vote. But now we're going to talk about cases where maybe one person gets 2 votes or one person gets 10 votes. And that's called weighted voting. We're not going to really see any of the same vocabulary, you know, the fairness criteria. We're not going to see Borda. We're not going to see any of that stuff. Really is different, even though the word voting is still there. The next 2 classes after these 2 are all about cryptography. And then finally, review day and our test coming up on October the 8th. In the meantime, the voting project is going to be due on September 24, 1 week from today. Questions on the calendar? All right, and like I said earlier, if you get that project done early, then submit it and I'll get it back to you early. Okay, we'll begin at the top of page 35 with number 1. Can we go to Ashley? Keep going.
From Wikipedia, critics urge that
Okay, so take a look at this map here. This is not in your packet. But when is the Electoral College used? For presidential elections. That is the only time it is used here in the US, is presidential elections. So when we talk about going to the polls every 4 years and voting for president, it seems like it's just a straight plurality thing because they don't ask us to rank anybody. They just say pick your favorite. But it is not the case that whoever gets the most votes necessarily wins the election. In fact, there have been a couple of times where the winner of the presidential election was not the person that had the most number of votes, but had the second most number of votes. So here are some numbers based on the Electoral College and all 50 states plus DC. Can anybody find the biggest number on this list? So we look all the way over there, 55 for California. That's the highest number. Next highest is down here in Texas, 38. Florida and New York are tied at 29, and then it meanders down to the smallest numbers we see, of which there are a bunch of 3s. Montana, the Dakotas, Alaska, District of Columbia gets 3, Delaware gets 3. Does anybody know like what these 3 people in Montana, like those are 3 actual people. Does anybody know, not their names, but who they are? Like the titles that they have? Those 3 people that are up there from Montana? Yeah?
I'm not positive. Are they the ones that are in Congress in the House?
Yes. Those 535 people are the ones that are in Congress and in the House of Representatives. How many senators does each state get? 2. Every state, regardless of size or population, gets 2 senators. So 2 of these 3 people right here listed for Montana are their 2 senators. And then states have different number of representatives in the House of Representatives based on what one factor? Population. Not about land mass. Alaska is a very enormous state in terms of land mass, but it's very tiny in terms of population. So California has 55 because it has 53 members of the House of Representatives. All right. So we are represented proportionally based on the 2 senators plus the population of each of the states. So as we look up here and we think about like how these votes get cast in the presidential election, suppose that that we have California's 55 votes. And in the last election, we had the Republican candidate and the Democratic candidate. And let's suppose that they were about even right? Californians go to the poll and they voted about 50-50. So do we take these 55 votes and cut them in half and give 27.5 to one and 27.5 to the other? How does it work? Simple majority rules, and it's a winner take all. So by getting the majority of votes in California, one person, one presidential candidate gets all 55 of those votes, right? And that's actually true in 48 of the 50 states, a winner take all, but surprisingly, there are 2 states where it is not winner take all. Up here in Maine, there are 2 congressional districts that can vote separately. They can each give 1 vote to whichever presidential candidate happens to win that congressional district. And then the other 2 remaining votes go to whoever gets the most votes in that state. And same thing in Nebraska, right here, there's 5. They have 3 congressional districts that can vote however they vote, and then the other 2 would go to whoever gets the majority of the votes in Nebraska. Okay, so how many votes do we have as a state of Massachusetts? We have 11. And this is how many we'll have in the year 2016, and it's how many we had in 2012. But in 2008, we actually had 12, not 11. Why did Massachusetts go from 12 down to 11 from 2008 to 2012? What happened in between? What's that? True. There was a population shrink. How did the government know? Sometime between 2008 and 2012. Census. Do you remember when the census happened? Just a few years ago. It was back in 2010. And based on the results of that 2010 census, the numbers shifted a little bit. Most states stayed exactly where they were with the number of representatives they had, but some grew and some shrunk. We shrunk by 1 vote. Okay, so we have 11 votes here in Massachusetts. California has 55 votes over there. So here's a natural question. How much more powerful is California than we are? 5 times. Isn't that reasonable? They have 55, we have 11, they're 5 times as powerful. So it turns out the right answer to how many times more powerful are they than we isn't as simple as just taking 55 and dividing by 11. And that's the question that we're basically going to be answering over the next couple of classes, is how do we decide how powerful people are or states are when they have different weights? That's what these numbers represent. So let's come back to the packet. And we will take, we'll jump down here to number 3, Ryan. Okay, so we're going to be not very creative, and we're going to call the people involved in this stockholder example P1, P2, and P3, standing for player 1, player 2, and player 3. And so player 1 votes yes or no on whatever is on the floor, and then player 2 votes yes or no, and player 3 votes yes or no, and then we count up all the yeses and nos, and if you get 12 votes saying yes, then the thing passes, otherwise it fails. And so we can look at that and we could say, okay, definitely player 1 is the strongest, and they're a little bit stronger than player 2, and it sure feels like player 2 is like 3 times as strong as player 3, right? But again, it turns out to not be as easy as that. So we're going to get into the nitty-gritty of that in a moment. But number 4, I'll read. We denote a weighted voting system as, and then there's some notation here. Q is the quota, and then the W1 up to WN are the number of votes owned by each of the players in decreasing order. The notation will become much easier when we actually have a specific example in front of us. And our stockholder example, here's how the notation always goes. It's square brackets, it's a single number followed by a colon, and then we'll list some other stuff. The single number in the front is Q, the quota. What's the quota in the stockholder example? 12. 12 goes right there. And then you list the number of votes that each player has in decreasing order. Strongest player has how many? 10. And then we separate these guys by commas. Then 9, then 3. And that is a very compact way to represent the stockholder weighted voting system, okay? The 10 and the 9 and the 3 are we call them the weights, but it's the number of votes that each player has. And we put them from biggest to smallest. Okay, let's move on to 4, Sam. 5, I mean. Okay, so lots of stuff in there we'll get into. What's the total number of votes in the partnership? So it says every 10,000 is 1 vote. And there's a total of $200,000 in there. So how many votes is that total? 20? You see that? 20,000 divided by the 10,000. So there's 20 votes total. And then it says that the quota, Q, is 2/3. 2/3 of the total number of votes. 2/3 of 20 is not a whole number. How much is 2/3 of 20? 13 and change, 13.3 and change. So what that means, so I'm going to write 13.3 and then I'm going to cross it off. So what that means is that in order for something to pass, it needs to have at least 13.3 votes. But again, that's not a possible number, so 14 is the minimum required number of votes. So cross that off and say, okay, got to have at least 14 votes. And then the last part says use the new notation to describe this partnership mathematically. So again, square brackets, some number and then a colon. What word describes that very first number? That's the quota. What number is the quota? 14, so we put 14 first. And then we're going to list the number of shares in decreasing order. So 14 first. And then remember, every 10 grand is a share. So this 80 grand person has how many shares? 8 shares. So 8 goes first. 70 grand means 7 shares, 30 grand, 3, and 20 grand, 2. So the notation is not hard, but I always get surprised on the first test when I ask a question just like that, where it says write it in our notation, and some people just flounder and just don't recognize that there's a tiny bit of work involved in translating the problem to the notation. So make sure you pay attention to that notation. 14 is the 2/3 of 20 rounded up. Yeah. Okay, 6 talks about some vocabulary. We're not going to write down all the formal definitions, but we'll mention some of these words now. Dictator, veto power, and dummy. Let's look at part A here. We'll go back to Eric for A. Okay. All right, so let's look at the idea behind the 10 votes number. So remember, if you have the quota, then that's enough to pass the motion, and it's also enough to squash the motion. So suppose that player 1 and player 4 say, yes, whatever this motion is, it's fantastic. We should totally do it. How many votes do they have combined? 10. And suppose that players 2 and 3 say this is the worst idea ever. We're going to put all our weight behind squashing this motion. Player 2 plus player 3. How many votes do they have total? 10. And if the quota is set to 10, then we've got like anarchy or something, because both the yays and the nays win, and that can't happen, right? So there's got to be some restrictions. You can't just willy-nilly make up a quota and throw it out there. So one rule that you'll see written mathematically in your book is that the quota has to be more than half the number of votes altogether. Altogether, we have 20 votes. 10 is not an allowable number, neither is 9, 8, or 7. 11 and up is what you have to do there. And then the next part says, what if the quota is raised to 19? So if the quota is at 19, we said there's how many votes altogether? 20. And the only way to get at least 19 is to have what happen? Everybody saying yes, right? So if the quota is 19, then unanimity is, I think that's a word, is required to pass anything. Anything. The only way that you can pass something is if it's a unanimous yes vote. I'm not saying that's illegal. I'm not saying it's a bad thing. I'm just saying that would require a very strong yes from everybody involved. Otherwise, nothing is getting done. Okay? And then finally, if the quota is 21, we don't have enough. And so if you set the quota too high, then nothing will ever pass, which is kind of silly. It means that there's no point in having this system at all. You can't accomplish anything, right? So again, your book will talk about some mathematical formulas about the quota. It's got to be at least this big, and it can't be bigger than this, and here's why. Tony? Yeah, I didn't write that down. Thank you for pointing that out. So I will say that in that case, both yes and no win, which is a problem. We can't have a motion simultaneously pass and fail. You're welcome. Okay, part B says consider this weighted voting system, 11, 12, 5, 4. How many players are in that example? 3. And we want to talk about what's going on with this partnership. So what can you tell me about power in that weighted voting system? Player 1 has all the power, right? Because player 1 can pass anything that they want to by voting, and players 2 and 3, even if they vote together, that's still only 9. That's not enough to match the quota. So so that's a dictator. So here, player 1 is a dictator. You remember how we opened talking about California's 55 and Massachusetts is 11? And I said it's not as easy as just saying California is 5 times as powerful. Well, this example should convince you that it's not as easy. Just looking at the 12 and the 4, how many times more powerful is the 12 than the 4? 3 times more powerful. But in reality, the 12 has all the power and the 4 has nothing. So we can't just do a simple division to decide the relative power of these people. Okay, 7, we'll go to Brendan. Okay, so let's go ahead and start with our standard form notation. Square brackets and a colon. You have a king and 4 advisors. So how many players are there? 5. There are 5 people involved in these decisions, right? The king and the 4 advisors. So we got to have 5 numbers up here. 1, 2, 3, 4 commas. Okay, so how do we tackle this problem? Some people want to start with the quota. That is a bad idea. I have no idea what the quota should be because I don't know what the numbers are that make up the system yet. So I can't start with the quota. Then some people want to start with the king. Well, the king is kind of special. The king is more powerful than the other folks, right? So to me, it seems like we should start with the weaker folks, the advisors, and let's just make up a number to give them some power. You could call them each 7 if you wanted to. It seems easier for me to just call them 1s. But I think there's a compelling reason for starting over here and saying, okay, 4 advisors, they're all equal. Let's just pick a number and we'll call them all 1s, okay? All right, so now I think we're ready to think about the quota. So these 4 people can band together and they can pass the thing, right? They can overrule. So in order for them to just barely be able to pass something, we've got to put this quota at 4. And then we got to make sure the king can't pass something by him or herself. 3 is a perfectly good number. And so what that means is that if the king gets how many advisors on board, he could pass something. King just needs 1. That's exactly what this system is describing. So that's it. Okay, number 8. We'll go to Leah. Okay, Ricky and Tony and Monica, come on up, please. All right. How many players are in this example? 3 people altogether, right? 3 players. The strongest player has how many votes? 3 votes. Tony, that's you. Good job. The next, is that 3? The next strongest player has how many votes? 2. I think I'm 1 marker shy here, so we're going to use a pencil. Okay, Monica, that's you. Well done. The weakest player has how many votes? 1. There you are. Okay, so here's the idea behind the way that we're going to talk about measuring power today. It's got a fancy name. It's called the Shapley-Shubik Power Index, and we're going to calculate it right now. So Shapley-Shubik, it's actually written right at the top right there. Shapley-Shubik. Okay, so here's the idea. We are going to take these 3 people, and we're going to have you guys standing in numerical order at the start. So Tony first, and then Monica second, and then Ricky over there. And we're going to have like a fishbowl over here that these guys are going to use to vote on the motion in front of us, okay? So here's the question. The question is, should we make spring break 3 weeks long instead of the normal 1 week? What do you guys think? That's all right. They're all in favor of this motion. So it's going to pass. So we got to figure out how it passes. So we're going to have them vote in order. And they're going to put their markers in here to say, yes, I think spring break should be 3 weeks long instead of just 1, okay? The quota for this guy is how much? 5 is the quota. So Tony's going to vote, and he's going to say, yes, all 3 of my votes, put them right in there. I'm in favor of this motion. Does the motion pass right now? No. Monica's going to come along and say, I'm in favor, and she's going to put all 2 of hers. So does it pass now? Yes. And so we're going to call Monica the pivotal player, because that was the one moment where this thing pivoted from being too light to just heavy enough. Or if you imagine like people sitting on a seesaw, you got this one weight on the one end that's 5 pounds heavy, and then you start stacking 1 pound weights on the other end until you find the magical person that happens to make the thing pivot, okay? So Monica was the pivotal player there. We're going to give you the votes here. Who was irrelevant to that motion passing in this order? It was poor Ricky. So we're going to keep track over here. We've got Tony was player 1, and then Monica was player 2, and then Ricky was over here player 3. And in that case, Monica was the pivotal player. She was the most important person, yes? She was the one that pivoted this thing from a losing motion to a winning motion. But that's only in this particular order, and this is really unfair to poor Ricky. Not only did I only give him one vote, but I didn't even get to him in this election. So what are we going to do? We're going to change the order. In fact, we're going to do all possible orders of these 3 people. Monica and Ricky, switch. And we're just going to let them all vote again. And they're still going to say yes. And we're still going to ask ourselves, who is the pivotal player? Who is the person that finally gets us to this thing where we know it's going to pass? We just got to figure out when. Okay, so I'm not going to use my little fishbowl anymore. But Tony votes. Hold your 3 markers up. Is that enough? No. Then Ricky adds his 1. Hold yours up. Tony, stay up. Is that enough? No. And then Monica puts her 2. Is that enough? Yes. So who's the pivotal player here? Monica, because again, she's the one that brought us from being under the quota to equal to or more than the quota. Okay, now we're going to change things. Monica, come on up to the front. You guys stay where you are. And we do the same thing. Monica, hold yours up. Is that enough? No. Tony, hold yours up. Is that enough? Yes. So who's pivotal here? Tony is. One over there. Sorry, Ricky. All right, Ricky and Tony switch places. Okay, and again, we go in this order now. Monica, is that enough? No. Ricky, Monica, keep yours up. Ricky, you gonna let them laugh at you like that? Come on. All right, so that's not enough. And then Tony, hold yours up, and that's plenty. So who's pivotal player there? Tony again. All right, who's the only person that hasn't had the chance to go first yet? Ricky. So Ricky comes to the front. And we're going to switch Tony and Monica just for a second, and then we'll do the other order. Okay, so Ricky votes first. Is that enough? No. And then Tony? No. And then Monica? Yes. So Monica has one more there. Okay, and then you guys swap there. Ricky goes first. Is that enough? No. With Monica, is that enough? No. With Tony? Yes. So Tony is there. All right, you guys can sit down. You look ridiculous. All right. Thank you. Okay. So, thank you. Here's our conclusion, is that Tony was the pivotal player 3 times, Monica was the pivotal player 3 times, Ricky was the pivotal player 0 times. So if you had to assign percentages of the power, and we're going to distribute the 100% of the power to these 3 people, how much power does Tony have? 50%, right? He has exactly half of there were 6 times that somebody was pivotal, and Tony was that person 3 times out of 6. So it feels like out of 6 gives us 50% for Tony, 50% for Monica. If I'm given a fraction over here, I guess I gotta do 0 out of 6 for Ricky's 0%. And this is one way to figure out how much power each person has. It seems like a pretty reasonable way because we took care of every possible ordering. So it wasn't like anybody got special treatment. We did every possible order of those 3 people. And in every case, somebody was the pivotal player, and we just recorded how many times that happened. So looking at the numbers, again, this first one was Tony, and there was Monica, and then that's probably in the way. Monica was that, and then Ricky was that. Just looking at the numbers, who did it appear was the most powerful? Tony, because he had 3, and then Monica with 2, and Ricky with 1. But in reality, it turned out that Tony and Monica, even with different numbers of votes, were both exactly as important as each other, right? They both were really important, pivotal, 50% of the time. And Ricky, with his 1 vote, might have had 0, it could have been 0 votes for all that it mattered, right? He was never the person that tipped the scales. So even though Ricky is technically a part of this system, he has absolutely no power, which isn't what it looks like because he has a vote. Okay, next page. Number 9. Okay, number 9. So we use this notation here with the kind of angled brackets, P1, P2, P3, to represent a sequential coalition. A sequence is just a list, but it's in a particular order. So if you see these funny kind of angled brackets, that's our way of saying, okay, first is Tony, second is Monica, and third is Ricky, in that order. And then we could shuffle them and talk about a different order. But you see those angled brackets, that means the order is something important. But next class, we're going to use different notation with the curly braces to indicate the collection of Tony, Monica, and Ricky, where it doesn't matter what the order is. So next class, we're going to come up with a completely different way to think about measuring power. It's going to be independent of order. But for right now, order is certainly important. Okay, number 10, let's go to Matt. Okay, so in our example that we just had here, there were how many players? All right, so I'm going to make a little table here. So N is the number of no, forget that. Number of players is going to be our first row. And then the number of sequential coalitions is second row. And we're going to start collecting some data here. So how many players again did we just have? We had 3. And how many coalitions, how many sequential coalitions were there when we shuffled all of the possible orders? There were 6, right? Okay, Now don't jump to any conclusions here. There are lots of relationships between 3 and 6, and that's not nearly enough information to figure out what the pattern is here. So let's take a step back to a smaller list of people. Suppose there are 2 players, players A and B. How many orders are there that you can shuffle A and B around? There are 2. It's either A and B or B and A. So if perhaps you were tempted to think that the bottom number was always double the top number, we now see that can't be the rule. Let's follow this back even one more. What if you just have 1 player? How many orders are there for player A? Just 1. Player A votes, and that's it. All right, I think we need 1 more number over here to try to really figure out what's going on. 12 seems like a reasonable number. I mean, we've got like a 6 up there. Maybe it's 12. Let's do this. I'm going to write down real quick the 6 possible orders that we just had for Tony, Monica, and Ricky. Let's do them alphabetically. So the first 24 is another possibility. M, R, and T. Okay, so here are the 6 possible ways that we could have had the 3 people up here. Last one is R. You don't need to write this down. But those were the 6 possible orders that we had with Tony, Monica, and Ricky up here. And now we're going to bring a 4th person into the mix, Sue Ann. So suppose that we look at just this possibility with Monica, Ricky, and Tony in that order. And then we're going to put Sue Ann someplace. Now Sue Ann could be first, right? Or we could squeeze her in second, or we could squeeze her in third, or we could put her last. So that one thing that's circled, the Monica, Ricky, Tony order, used to be 1. Now how many is it with Sue Ann in the mix? How many possibilities are there? There's now 4. And in that ordering, we could put Sue Ann in any of those 4 spots. So each of these 1 things branches off to 4 more possibilities as soon as we bring a 4th person in. There are 6 of those things. So how many will there be when we put Sue Ann in everywhere? There's going to be 24. You see that? Each of those 6 things becomes 4 new things. So it turns out this right here is a 24. And that will give you the punchline. If we keep this up forever and just kind of put a generic N right there, turns out that N, with an exclamation point after it, is the number of sequential coalitions. Does anybody remember how you say that exclamation point in a math class? No, it's not that. It starts with an F. Anybody know how to say it? All right, so it's called N factorial. Maybe you've seen factorial before. And I'll just write a quick example here. 4 with an exclamation point on it means, Zeke, I think you know what it means. What does it mean? What does? That's what 4 exclamation point means. It means you start at 4, and then you multiply by the next number and the next one all the way down until you get to 1. Just keep going until you get to 1. All right, let's do the calculation. 4 times 3 is 12, times 2 is 24, times 1 is 24, which is exactly the right answer for the 4 number. And so if I wanted 6 factorial, we would start with what? 6, and then multiply by 5, and then 4, and 3, and 2, and 1. Okay, so here's what we're going to do. We're going to do this this process that's listed right here, which is something called the Shapley-Shubik Power Index. It's named after 2 people, Shapley and Shubik. Again, this is a fairly recent invention. I'm pretty sure Lloyd Shapley is still alive, and he recently won something. It wasn't quite the Nobel Peace Prize, but it was some other really high echelon award. The point is, you are not studying math that's 3,000 years old. You're studying something that was made by people that are still alive. I actually don't know if Shubik is still alive. I should look that up. Hopefully he is. Okay, so this process, A, B, and C, is just the formal writing out of what we saw with our 3 people and their markers. So you list all the sequential coalitions. We had 6 of them before. You find the pivotal player in each coalition. There's always one person that turns it from a not enough to a enough. And then to find this thing, which we call the Shapley-Shubik power index, we're going to do fractions. I'll remind you that that was our answer over here. We took Tony's 3, we divided it by 6. Why 6? 6 was the total number of pivotal players, the total number of sequential coalitions. So 3 times out of 6, Tony was really important. 3 times out of 6, Monica was really important. So we're just going to count however many times somebody's important, and we'll make that the denominator of all the fractions. And that's it. So let's try it for number 12. We're going to do this process for number 12 without the markers. So we're going to find the SSPI, Shapley-Shubik power index, for this sequential coalition, this weighted voting system, 5, 4, 2, 1, 1. How many players? 4. How many sequential coalitions when there are 4 players? 24. All right, to save you some time, I have listed those 24 things right here. And there are several copies of this grid on the very first page of the packet for you to use when you're doing tonight's homework. So you don't have to write this over and over again. It's there for you. And so let's give it a shot. So here's the first thing that I recommend. It's a little bit time consuming, but I think it makes things really clear. I'm going to go through all 24 of these, and I'm going to put next to P1, how many votes does P1 have? 4. So I'm going to go down here and put 4s right above all the P1s. And then once I finish that, I'm going to go to the P2s and put how many votes? How many votes did the second player have? Was 2. And so I'm going to find all those P2s and put a 2. And then P3 and P4 each have how many? 1. And so I'm going to end up with numbers on all of these guys. So take a minute, carefully, slowly, and put numbers on everything. Okay, so let me just say that as you fill all those numbers in, I think it's better to put 4s on all the P1s first, as opposed to going each coalition in order. I think it takes more time to go each coalition in order. So I find all the P1s, I put 4s on all of them, and then I put 2s on all the P2s. Do it however you want. Okay, but now it's time to get into the nitty gritty and actually find the pivotal player. And in the pivotal player's case, that number 5 right there, that quota is super important. We're looking for the first person that puts us over the tipping point, at least 5. So we imagine the first player putting 4 yes votes into our bin over there. Is that enough? No. And then the next player comes in and puts 2. Is that enough? Yes. So that 2 is the pivotal player. I'm going to circle it. I'm not circling the 2, I'm circling player 2. Don't circle the 2, circle the player. Okay, in the next row, is the 4 enough, the very first 4? No, and then how about 2 more on top? Yes, it is, so we circle player 2. We're going to do 2 more of these together, and then you're going to do the rest in your groups. In the next row, first there's a 4, is that enough? The 4. And then there's a 1, is that enough? Yes, so this is maybe the first time we're thinking about a tie, but 5 is the quota, and that's enough to pass it. So ties are good enough. So player 3 gets circled. The last one I want to do is the very last quota on the page, all the way at the bottom right. So let's do this one, and then you'll work on the rest in your groups. The first person puts 1 vote into the pile. Is that enough? No. The next person puts another vote, so we're up to 2. Is that enough? No. Then we get 2 more, which means we're at 4. Is that enough? No. So we don't tip the scales until we get to the last person, when finally we have however many, 8. So player 1 is pivotal there. Okay? So carefully work through. Once you finish the first column, check with your neighbors before moving to the next column. So we've got our things very carefully circled. Now it's time to carefully count. So P1, P2, P3, and P4 each get counted a certain number of times. So we just have to count how many times each player was circled. Now P1 is circled way more than anybody else. So 18 is what I've seen. So you just have to very carefully count 18 times for player 1. And then player 2, just these two right here in the very beginning. And then player 3 is also only 2. Where are those ones? Oh, it's in the first column. Yeah, these middle ones in the first column. And then player 4 is only the last ones, 2 and 2. Okay. Now, despite the fact that I say on the test, make sure your answers are fractions, some people stop right here. That's not done. We're looking for percentages. These numbers are meaningless without giving them something to compare to. What do we divide by? 24. There are a couple of ways to get the 24. You can add 18, 2, 2, and 2. Just count how many times was anybody pivotal. There are 24 of them. Or you could count how many things are in the grid. There's 24 of those. So everything divide by 24. You can leave these answers as they are. You can reduce these fractions if you wish. You can write percentages if you wish. 2 divided by 24. Can somebody type that in? About 8. Full credit. Those very first fractions we wrote are full credit. If you want decimals, then go for it. If you want to reduce the fractions, go for it. But as soon as you get those fractions written down, you're getting full credit. Okay? So that's it. The first player has 75% of the power. The other players are equal, about 8% each, 8 1/3. Is this surprising? Well, kind of. If we look at player 2 compared to the other two guys, maybe we would think, well, let's see, 2 votes to 1 vote, that's twice as good, twice as powerful. Was it? No, it was equal. So again, it's just not as easy as looking at the numbers and dividing. You really have to do some more work to figure out what the distribution of power is. All right, we have 27 minutes. See how far you can get in this frontier power activity. Raise the flag if I can help.